This tutorial is going to be an introduction into looping using a for loop. Now there's different types of loops that you can use in Java. For loop is very useful primarily when you know how many times you want to loop. So let's talk about what loops are, right? So computers, one of the most powerful parts of a computer that differentiates it from a person is that a computer is excellent at doing the same exact thing over and over, right? Whereas a person in general is not. A person's really good at doing something once, right? But if you ask the person to do that same thing 1,000 times or 1,000,000 times, typically they're going to find shortcuts. They're not going to do it as well. They're going to get lazy. But a computer is going to do it over and over the exact same way every time. So let's talk about the structure of a for loop, right? So the structure of a for loop is broken into three parts, and I'm going to type something that's simple, and then we'll talk about it, right? I++, and I'm going to print out. I'm going to put brackets there. So I'll just print out I. Okay, so let's talk about this for loop and what it means. So there's three parts of this for loop in parentheses, and they're separated by semicolons, right? So let's talk individually about each part. The first part of the for statement is the initialization part. So basically this happens before the for loop starts, right? So basically I'm saying I'm defining a variable called I and I'm assigning it a value of 1. That happens before the loop starts. Now, the last thing here happens at the end of the loop each time it goes through this loop, right? So it happens when it gets down to this bracket before it goes back up to the beginning, right? Because a for loop keeps cycling through these lines over and over based on this condition. So the I++ happens as I get down here and I come back up ready for the next one. And this middle statement is actually the condition. So it's only going to stay in this for loop if this condition is true, if I is less than or equal to 10. So let's think about this. I set I to 1 at the beginning, happens one time. Then I say, is I less than or equal to 10? Yes, it is. So I'm going to execute what's in here. And there could be more than one line in there. There could be hundreds of lines, right? And then it's going to get down to this bracket, and it's going to say I++. So now I is 2, right? And it's going to come back up, and it's going to say, is I less than or equal to 10? Yes, 2 is less than or equal to 10. So again, it's going to do whatever's in this loop, come down here, say I++, now I is 3, then it's going to come back up to the condition, is I less than or equal to 10? Yes, it is, right? So let's make it 5, right? So how many times will I actually execute this list? Well, I'm going to execute it when I is 1, I'm going to execute it when I is 2, when it's 3, when it's 4, when it's 5. Now, when I get down here and increment again and I is 6, it's going to come up and say, is I less than or equal to 5? Well, 6 is not less than or equal to 5, so it's going to drop out of the for loop to whatever is on this next line, which is nothing in this case, right? So let's run this code, right? If I click run here, I see it goes through the loop and prints from 1 to 5. If I change this 5 to 10, right, and I run it, now I'm going to go through and it's 10. Now, here's the incredible part of computers, right? If I make this, 1,000, it's gonna run through 1,000 times, right? And you could see that it went through 1,000 times, right? If I scroll through, right? So computers, once again, are brilliant at doing things many, many times. So that's the way a for loop works. Now, one thing to mention. I didn't have to declare the variable in the loop. I could declare the variable up here int I, right? And I could just say I equals 1 here, and it initializes it to 1. So when I come out of the loop, if I display the value of I after loop, right? If I print out I, I still exists after the loop. If I run it after the loop, I is 6. Because remember, on that last time through the loop right here, it incremented I. It did I plus plus. It said I was 6, and it fouled this condition. It dropped out of the loop, and I was 6 when it dropped out of the loop. Now, oftentimes, we don't really need I or whatever I name I could call it counter, right? I could call it counter, right? Oops, counter. Typically, you're going to see people use I because in a loop because they're only using it to work in the loop. But I just want to show you there's nothing special about I, right? It's counter. I could name it any variable I want, right? Counter, after loop, counter, right? Okay, and then declare counter here, right? Okay, so I could use counter. I'm going to get the same thing, right? Counter after loop. Okay, so there's nothing special about I or counter. However, you are going to see it I. Now, most of the time, though, we don't really need this counter after the loop. We don't need it before the loop. We don't need it after. We just need to count within a loop to do something a certain number of times. So most of the time, you're not going to see it be declared there. Now, here's a big difference, though. When I do for int I equals 1 or int counter equals 1, since this variable was declared kind of within these brackets, within the for loop, that variable counter doesn't exist anymore outside that loop. Look, this is giving me an error right here. It's saying counter can't be resolved to a variable. It's saying, hey, counter doesn't even exist. So when you're using a loop and you only need a variable to count or to index within the loop, declare it actually in your for loop, and then it won't even exist outside of your loop. So the most traditional one is I, and the reason for that is because it's short, it's quick to type, right? But the thing you need to remember is I doesn't exist anywhere except in this for loop, right? It just exists in that for loop. So that's the way a for loop basically works. You initialize it to some value, you test every time through the loop, and at the end of each increment of your loop, here's what's happening. And you don't have to go by ones. You don't have to do I plus plus. I could say I equals I plus 3, right? You could do that, right? So now what's going to happen, right? If I run through this loop, right? I is 1, then I is 4, then the next time it's going to be 7, but it's not going to pass through that condition, so it's just going to drop out, right? If I want to go by 2s, I could say I equals I plus 2, right? And then 1, 3, 5. I could start I at an even number, it's like 2, right? And I could increment and get 2, 4. If I do I is less than or equal to 10, now it's going to be 2, 4, 6, 8, 10, right? 2, 4, 6, 8, 10. I could use shorthand notation over here. Instead of I equals I plus 2, I could say I plus equals 2, right? And increment by 2 each time. So again, the key component is this is what it gets initialized to one time before the loop. This is the condition that keeps you in the loop. And this is what happens at the end of each increment of the loop. Now, there is another structure for loops. It's actually a for each, but I'm not going to go over those yet because that's useful when you have when you have arrays, right? And we didn't talk about arrays yet. So for now, this is the structure of your for loop. And you can play around with that to see how to go through loops by incrementing by 1, by incrementing by 2. You could also decrement, right? Let's say I wanted to count from 10 to 1. I could initialize I to 10, right? I could say as long as it's greater than or equal to 1, right? Then I want to decrement, right? I want to go down. I want to decrement. So now I is going to start at 10. It's going to stay in this loop as long as it's greater than or equal to 1, and it's going to decrement each time, right? So if I run this code, right, now I go 10, 9, 8, 7, 6, 5, right? So that's the way you go backwards through strings. And I could count down by 2s, I could count down by 3s, I could do whatever I want at that point.